Just picking up where we have left off, and we started going into a problem set on page 113. And again, much of the items we have revolving around quadratic equations, fractions, and also we have in the mix. Okay, we have factoring, and we have, in the case of number 47, okay, we're looking at factoring completely. Okay, the trinomial. Okay, whereupon we have 8x cubed minus 40x squared y plus 50xy squared. And looking at factoring, okay, notice that the leading coefficients are even values, and we have the variable x common to all three expressions, whereas y is limited to just the last two terms. And looking at initiating the factoring, okay, we can draw out the greatest common factor and the highest number divisible into 8, negative 40, and 50 is going to be at 2. And considering that we have at least x in common, it's going to turn out that the greatest common factor of this trinomial is going to be 2x. So looking at factoring 2x, we now have this expression to be the product of 2x and what is going to be 4x squared, and 2x into negative 40 x squared y is going to be a negative 20 xy, and 2x into 50 xy squared, okay, this is going to be 25 y squared. Okay, so we are at this stage. Okay, so we have the greatest common factor at 2x. Now for the trinomial, after dividing or factoring out 2x, is going to be one that we can factor in its own right. Okay, and so for the trinomial, 4x squared minus 20xy plus 25y squared. Now we have the proportions among the coefficients, and also we have the right variables where I can factor this particular trinomial. And looking at what we have in the mix, okay, looking at factoring by grouping. Okay, so drawing out the first and the last coefficients and multiplying together. So I have 4 times 25, okay, and so we will have the product at 100. Now in turn, looking at factors of 100 that will add up to the middle coefficient, minus 20. And they will not be the factors we had to form the initial product 100. Once again, we got to the product 100 upon multiplying 4 and 25, and those values add up to 29. Okay, we want a negative 20 sum, and so in what we have now, okay, so if I had changed this over to like negative 4 and negative 25, okay, your sum will be at negative 29. So I'm going to have to adjust the absolute values of these factors, okay, where the sum is going to be at negative 20. Okay, so in other words, where the sum is going to be the absolute value of 20, but where we're going to have the sum to be negative 20. So we got negative 10 and negative 10. Negative 10 times itself will form 100. Negative 10 plus itself is going to be negative 20. And so this will be the combination that we need in the follow-through if we are to factor by grouping. So we have with 4x squared minus 20xy plus 25y squared. Again, the negative 10 and the negative 10 will form xy terms. Upon splitting up the negative 20xy, so we have in setting the stage, okay, so we got 4x squared once again, we're going to have back-to-back xy terms with a coefficient -10. And looking at grouping, okay, so putting the first two terms in parentheses. So I have 4x squared minus 10xy, and separating the first two terms apart from the last two, I have the operation of subtraction, and looking at representing the quantifying of the last two terms. Again, I'm doing this in the manner of factoring out a -1. Okay, so it got -10xy would be the opposite sign of 10xy, and for 25y squared, that would be the opposite sign of minus 25y squared. And looking at drawing out, okay, the greatest common factor, so you have 4x squared and -10xy, and the highest term that will go into both of these terms. Okay, so we're going to have at 2x and taking into 4x squared minus 10xy, so we're going to have 2x minus 5y, and bringing down the subtraction, and we have for the next greatest common factor, so between 10xy and -25y squared, okay, so you're going to have 5y, and taking 5y into 10xy minus 25y squared, so we're going to have 2x, and 5y into -25y squared, so we're going to have another -5y. And looking at what we have in the formation, okay, so you have the quantity of 2x minus 5y, and you have times the quantity, okay, the outside terms, which we have at 2x minus 5y, and we have in the result, okay, so we're going to have with the repetition of 2x minus 5y, so this will become 2x minus 5y quantity squared. Okay. And so just looking at what we have in the overall picture, and what I'll do here is just sort of shrink this up. Okay, so I factored this trinomial, okay, and going back to the initial setup, okay, so again, the greatest common factor was 2x, so that factor is drawn out, and with the trinomial, okay, this was factorable, and so just transporting the square of 2x minus 5y to the original settings, it's going to turn out that for the final results in the factorization of what we have in number 47, so we're going to have 2x times the square of the quantity of 2x minus 5y. And that would be the final result. Okay. Now, in looking at what we have also in factoring, and we have with number 54, okay, again, now your first exam is going to have factoring involved, and in this one, in 54, now we're going from the variable x, okay, to the letter m, and here we have m to the 6th plus 9m cubed plus 8. Okay. Now, we don't have an equation, but we do have a trinomial that is quadratic in form. Again, an expression quadratic in form if it has two terms in the same variable. The higher degree variable factor is going to be twice the degree of the lower. Okay, and so we have m to the 6th, m to the 3rd. So we had this expression would be quadratic in m to the third. And I had the coefficients such that I can factor. Okay, so for m to the 6th, this will go to m cubed and m cubed. And for factors of 8, that will add up to 9. Okay, so I'm going to have a plus 8 and also a plus 1. And now for here, we have sums of cubes in the expression. And I don't think your first test is going to have directly dealing with the factorization sums and differences of cubes, but they will in a sense reappear once we get into polynomial division. Now again, just going back for what we have in the case of the sum of cubes, like you could have again the general expression a cubed plus b cubed, and this would factor to the quantity of a plus b times the quantity, where we have in the trinomial we have a squared minus ab plus b squared. And for what we have in the case of m cubed plus 8, okay, so you have for m cubed plus 8, okay, so m cubed is going to be the cube of m, and 8 is going to be the perfect cube of 2. Okay, so we're looking at m to the third plus 2 to the third. So you can look at a as being represented by m, b represented by 2. And for a plus b, we can say we have m plus 2. And for a squared, that's going to be m squared and minus a times b. So again, have the subtraction of the product of m times 2. So that will become the subtraction of 2m. And b squared, that's going to translate to 2 squared, which is going to be at 4. And as for what we have in m to the third plus 1, okay, 1 is going to be the cube of itself. So think of it along the lines of where a is at 1 and a is at m and b is at 1. Okay, so we're going to have m plus 1 for a plus b, and for the trinomial a squared becomes m squared minus a times b is going to become minus m times 1, which would be minus m, and b squared is going to be 1 squared, which is going to be at 1. Okay. And so just taking these results, and it's going to turn out that for the factorization, what was this original 6th order trinomial expression? Okay, so this is going to come down to where we have for m to the 6th plus 9m cubed plus 8 in the completely factored form. Okay, so we have from m cubed plus 8. So you have m plus 2 times the quantity. Okay, we have m squared minus 2m plus 4. And as for m cubed plus 1, again we'll have m plus 1. And we have times the quantity of m squared minus m plus 1. Okay. Again, that was a bit drawn out, okay, since we were looking at multiple layers of factoring, okay, going from 6th degree to 3rd degree expressions, and then considering that the 3rd degree expressions are perfect cubes, we took those on out even further on the basis of factoring the sum of cubes. Right. Now, also in sections ahead, okay, we'll be looking at what will be regarded as domain. And for what we have in 61, okay, this touches upon this. Again, just going back to restricted values. And for what we have in the set for 61, Now we're looking at reducing a rational expression and identifying, okay, just what will be the restricted values. And again, restricted values are going to be those amounts, okay, that are not allowed for m. And what would those values be? They will be those which would cause the denominator to be 0. Okay, and in the real number system, a fraction cannot have a 0-valued denominator. And if we go ahead and just identify what the restricted values will be, again, we cannot have a 0 denominator. In other words, we cannot have the 0 bottom part of the fraction. And so for m squared minus m minus 12, this cannot be 0. And pinpointing just what values of m will be excluded. Okay, so if we look at factoring, okay, so we have with the factors of this trinomial, and we have m minus 4 and m plus 3. Again, negative 4 times 3 is negative 12, and negative 4 and 3 would add up to negative 1. And now we're utilizing the zero product property, but we're looking at what will be excluded, okay, since we cannot have 0. Okay, so if m minus 4 cannot be 0, okay, we have that m cannot be 4. And we have for m plus 3, if this cannot be 0, so we have that m cannot be negative 3. And so we have for the restricted values, okay, we have a 4 and negative 3. And for what we have in terms of reducing this ratio, okay, so we have at the top, okay, it's going to be a difference of squares. Okay, and if I factor, so I'm going to have m plus 4 and m minus 4. And again, with m squared minus m minus 12, I'm going to have m minus 4 and m plus 3. And notice we have a common expression between the numerator and denominator with m minus 4. So we're going to have these to cancel out. So this will become m plus 4 all over m plus 3. And this would be the simplified form of this ratio. And let me mention, okay, again, for the restricted values, they come not from the simplified form of the ratio, but the original, okay, because from the original, for this to be defined, m cannot be 4 or negative 3. But if I had started out with this ratio, where there had been just one restricted value, and that would have been that which would keep, or would cause m plus 3 to be 0, so that would have been just negative 3. But with the original ratio, okay, you had to go with the original form and find out what would cause the denominator to be 0, and so we have 4 and negative 3 to be those particular excluded values. Alright, and looking at rational expressions, now we've worked with combining fractions as well as solving rational equations where we cleared out the denominator of fractions. And now on the side of looking at combining rational expressions, we have for number 65, okay, we have two fractions with unlike denominators, where we have 7 over 20x added to 2 over 15 times x to the 4th. Okay, so I cannot directly add these fractions together with the way the expressions are laid out, and I had to put the denominator in terms of something that both 20x and 15x to the 4th will go into. So we have just looking at each of the items being the the denominators and their factors. Okay, so we have with 20x. So if I take 20, and if you can intuitively see just what the least common denominator is, that's fine. But just kind of showing the breakdown for 20. Okay, we can say we have factoring out primes. Okay, so you have 2 times 10. 2 is a prime. 10 can be factored into primes. We have 10 is going to be 2 times 5. In the case of 15, now 15 is going to factor out to 3 times 5. And in the case of the prime factor, prime factors, okay, we'll just call those the primes. Okay, so you have the numbers 2, 3, and 5. And there's only one variable factor. And that's with the letter X. All right. And looking at what is going to be the least common denominator. Again, this can be formed by the greater or greatest number of appearances of each of the prime factors. Okay, so we got with 2, it doesn't appear in 15, but it does appear twice from 20. 3 doesn't come or emanate from 20, but it does come once from 15. And 5, the greatest number of appearances of 5 in either factorization is going to be just one time. And so on the numerical side, so we got a couple of 2's. We have a 3 and a 5. And for the variable factor x, we'll go with the higher or highest degree in this case, which is going to be x to the 4th. And multiplying, so you got 4 times 3 is 12. 12 times 5 is 60. And the smallest term that both 20x and 15x to the 4th will both go into is going to be 60x to the 4th. And so working with these ratios, so you have 7 over 20x and 20x into 60x to the 4th. Okay, so you got 20 into 60 is 3. And x into x to the 4th is going to be x cubed. And for 2 over 15, x to the 4th. Okay, we had the 4th degree in x, and so it just comes down to how much 15 will go into 60. In this case, it'll be 4 times. So the second ratio will be multiplied by 1 in the form of 4/4. And looking at putting it all together. Okay, so both denominators, okay, will be 60x to the 4th. And I can go ahead and consolidate. And looking at the numerators, so you have 7 times 3x cubed. So this will be 21x cubed. And we got plus 2 times 4, okay, which is going to be 8. And this will be the final result. So you have 21x cubed plus 8 all over 60 times x to the 4th. All right. Now, also in dealing with rational expressions, okay, and we have with number 67. Now we got not 2 but 3 fractions. And we're looking at making into one overall expression. And here we have 4 over x squared. And we have plus 3 all over x plus 3. We have minus 2 over x. Okay, so you have variable expression factors. And we'll go ahead and get to the least common denominator. Now for the standalone letters, okay, so you have x by itself in the first fraction and with the last, okay, and least common denominator will contain the higher order in the standalone x. So this is going to be x squared, and we have for the middle fraction, okay, that is going to be the only one that has a denominator, okay, that is in the form of the binomial x plus 3. So to put all this into the least common denominator, the smallest term or expression that all of x squared, x plus 3, and x will go into will be x squared times the quantity of x plus 3. And so setting things up, and we have for 4 over x squared, okay, so we got x squared, and so we have x plus 3 left over. And we have plus 3 over x plus 3. And looking at x plus 3 relative to the least common denominator, okay, we had the x plus 3, but we need the x squared portion. Okay, now for the last ratio, this one is going to have a requirement of an added layer of concentration. Now we have 2 over x. We have x to be first degree, and taking this into the least common denominator. So we have x and x squared. Okay, this will leave a degree in x. And furthermore, we have the x plus 3 factor to consider. So for what we have here, okay, all these denominators should be in the formation of x squared times the quantity of x plus 3. Okay, so you have with the first, you got x squared x plus 3, x squared x plus 3, x times x is x squared, and then you have times x plus 3. Now we have with the numerator expressions, okay, so if I distribute 4 over the quantity of x plus 3, okay, this will make 4x plus 12. Okay, and then we have next, we have 3 times x squared. And we'll just take this out one step further. So you got minus, and you got 2x times the quantity of x plus 3. Okay, so for what we got here, so you have x squared times the quantity of x plus 3. And again, we have 4x plus 12. Plus 3x squared, and then for the distribution at the end, so you got negative 2x times x, so we have negative 2x squared, and negative 2x times 3, so we have a minus 6x. Right, finally, okay, we have upon combining like numerator terms, and just putting these in descending degree order. Okay. So first of all, so you have highest order terms, you have 3x squared and negative 2x squared. 3x squared minus 2x squared becomes x squared. And for the first order terms in x, we have 4x and minus 6x. 4x minus 6x would become negative 2x. And we have at the end, we have plus 12. And so we finally have, okay, and taking the combination of 4x squared, 3 over x plus 3, and minus 2 over x, we come out to the consolidated ratio where we have x squared minus 2x plus 12 all over x squared times the quantity of x plus 3. So numbers 67 and 76, okay, concern combining rational expressions. And now in the next phase for what we have in blending, okay, quadratic and also rational equations, and we have for number 80, and we're looking at solving, okay, for the variable y. And this equation, okay, so we're looking at the solution or the solutions to y, such that 3y squared minus 4y is equal to 8 minus 6y. Now, we have a quadratic equation, but we do not have it presented where it is quadratic in standard form. And if I do this standard form again, where the expression is set equal to 0. Now the highest order term is 3y squared, and it is situated on the left. And if I move the terms from the right over, so I'm going to add 6y to negative 4y, and just move the 8 over by subtracting. So we have 3y squared, you know, negative 4y plus 6y. Okay, that's going to be a 2y. And we have minus 8. And we have this equal to 0. And now we got a trinomial that is factorable. Now, before I look into factoring, again, if you were to utilize the quadratic formula, okay, that is a viable approach, but it would require like extra steps in terms of reducing. But you can use the quadratic formula for this. And now, just for the trinomial, 3y squared plus 2y minus 8. Now I could do a little bit of guessing to find out what the combination of binomials will be, because 3y squared, this would go to 3y and y, and the question would be, okay, after 3y, would I be adding or would I be subtracting? Same thing for y, would I be adding or subtracting? And just looking at what we have in the combinations case, so you have, looking at the first and the last coefficients, so I have 3 times negative 8, which we'll have at negative 24. And upon looking at the factors of negative 24, that will combine in terms of adding or subtracting to positive 2. So more weight's going to be given to the plus factor than to the minus. And so looking at what we have in this situation, okay, so start out with 3 and negative 8. 3 times negative 8, okay, you have negative 24. However, 3 plus negative 8 will be negative 5. And if I change the signs, you have like negative 3 and 8. But again, the sum is going to be positive 5. But I want the sum to be positive 2. So if I just slightly modify, just kind of get it closer to balancing in terms of the respective absolute value. So if I just add to the negativity with minus 4 and just lower the positive factor to 6, we got negative 4 times 6 is negative 24, and negative 4 plus 6 is going to be a positive 2. So these are the coefficients we're looking for. And for 3y squared plus 2y minus 8, if we take what we got here and split up the 2y into variable terms for the coefficients of -4 and 6. And again, it doesn't matter what order you place the coefficients, but I recommend if you got, again, I've said this before, if you got a negative factor and a positive factor and you're setting up factoring by grouping, have the positive term to follow the negative so that the operation in the middle, that is, which will be located between the first and second pairs, will be addition. And so that would kind of make the factoring and the grouping of parentheses a quicker, I would say, and definitely a simpler process. Okay, so here we got 3y squared, and we got minus 4y, we got plus 6y minus 8, and looking at grouping together, so you got 3y squared minus 4y, and we have in the middle, okay, is the operation of addition. And I can just go ahead and put directly in parentheses 6y minus 8. And looking at drawing out the greatest common factors, okay, for 3y squared minus 4y, okay, we have limited to y, and into 3y squared minus 4y, so that's going to be 3y minus 4, and bring down the plus, and we have for 6y minus 8, greatest common factor is going to be just the number 2. And this is going to 6y minus 8, 3y minus 4 times. And so for what we will have here, shared in common between the groups, we have 3y minus 4, and with the formation of the binomial upon clustering together the outside terms and the operation that was central, okay, we have the quantity of y plus 2. So those will be the factors. And so just looking at what we have now, in the case of the quadratic equation concerned, okay, so again we have 3y squared plus 2y minus 8 is equal to 0. And so drawing out the factors, we got the quantity of 3y minus 4 and the quantity of y plus 2 is equal to 0. And so just looking at each of the factors, again, looking at the zero product property. So yeah, with 3y minus 4 equal to 0, if I separate the variable term 3y apart, that is, if I set 3y apart from 4, I have 3y is equal to 4, and we have with division by 3, we'll have that y is equal to 4/3. As for y plus 2 is equal to 0, if I take 2 away from both sides, okay, we're going to have that y is equal to -2. So we have, for this particular equation, we have 2 solutions for y, one being a positive non-integer with 4/3, and the other as a negative integer in the amount of -2. All right, now looking at blending in with quadratic equations, you also have in the mix, okay, we have okay, what will be radical equations, and just looking at what we have in the mix and just seeing what we've got now. Say in number 76, okay, and we're looking at going back to the letter M. looking at solving for m, whereupon we have m plus 2 over 3. We have minus m minus 4 over 4 is equal to m plus 1 over 6 minus 1. Alright, so you have three fractions, and on the far right we just have, in direct terms, we have the negative 1. Okay, and so we have, and you can probably already see what the smallest value will be upon which all of 3, 4, and 6 will go into. And I'm just going to draw out just the prime factor. So 3 is already a prime number. In the case of 4, let's go to 2 times 2. And for 6, this will factor out to 2 times 3. And again, we have with the primes. No variable in any of the denominators. So you got your primes at 2 and 3. And for the least common denominator, okay, so you have with 2, we draw upon the greatest number of appearances among the factorizations. So you have a couple of 2's from 4, and with 3, you can pick and choose either one. It appears once from 3, not at all from 4, and only once from 6, so we have 1, 3. And for the LCD, okay, we have 2 times 2 is 4, 4 times 3 is 12. Okay, and so in this case, now for these fractions, okay, in solving, since we have an equation, we can use the least common denominator to cancel out the denominator. And why am I doing this as opposed to what we did earlier in the case of number 67, or even in the case of 65? Well, remember, 65 and 67 required the combination of terms, and there was no equal sign, so there was no equation involved. But now with the equal sign, we have an equation, so we are at liberty to clear out these fractions. Okay, so looking at distributing what we have here, okay, so you got 12, and you got times the quantity of m plus 2 all over 3. I can bring down the subtraction here. You got 12 times. We have, again, m minus 4 over 4. And that is equal to 12 times. Again, we have m plus 1 over 6. And we got minus, okay, and we have 12 times 1. So looking at reducing, and you can think along the lines of cross multiplying. So you have 12 times m plus 2 over 3. And get the 3 out. 3 goes into 12 4 times. So we're going to have 4 times the quantity of m minus 2. And we can go ahead and bring down the subtraction. Now 4 will go into 12 3 times. And having brought down the subtraction, so we got subtraction of 3 times the quantity of m minus 4. And for what we have to the right, okay, so you got 12 times m plus 1 over 6, and 6 will go into 12 2 times. So 2 times the quantity of m plus 1, and we have minus, and 12 times 1 is 12, so you have minus 12. Alright, so without any denominators, okay, we can go ahead and distribute. First case, 4 over the quantity of m plus 2. Okay, that is going to be a 4m plus 8. And negative 3 over the quantity of m minus 4. So we have minus 3m. Minus 3 times negative 4 is going to be a plus 12. And to the right, 2 times the quantity of m plus 1. That is going to be 2m plus 2. We have minus 12. And combining the like terms. Now to the left we have 4m minus 3m becomes m. 8 and 12 will make 20. And to the right, so I have 2m plus 2 minus 12 becomes negative 10. And now we have two sets of like terms on opposite sides. What I'll do here, okay, is that I will work with the variable terms first, and I'm going to eliminate the smaller of these. In this case, we have m to take out, and also at the same token, while I have the m terms on the right, I'll just move the 10 over by adding. So 20 plus 10 is going to make 30, and 2m minus m becomes m. And so for this equation, okay, there is one solution for m, and that is going to be 30. Okay, all right, and along with rational and quadratic equations, okay, we also have in the mix, once again, radical equations. And from this group, okay, say in number 86. Okay, so with radical equations, again, there was that fundamental that was mentioned with the principal square root rule. And again, you have like even root radicals cannot have expressions to reduce to a negative constant. But again, that rule does not apply to odd root radicals. And for what we have in the case of 86, now we have an even root radical with the square root. And here we have the square root 51 minus 14x, followed by the addition of 4 is equal to x minus 2. So you have only one radical term with the square root of 51 minus 14x. And if I get this by itself, I can just take away 4 from both sides. So taking 4 away, so I have the square root of 51 minus 14x. To the right, I've got x minus 2 minus 4 will become x minus 6. So again, I have one radical term in the form of the square root 51 minus 14x, and I can eliminate the presence of the radical upon squaring both sides. Okay. So left hand side, then we have that 51 minus 14x. And for the square of x minus 6, again, you're looking at x minus 6 times itself. My x times x is x squared. Then we have negative 6x, and another negative 6x will make negative 12x. And negative 6 times itself, okay, we're going to have at plus 36. And we have the formation of a quadratic equation with the highest degree term on the right. And if I convert this to standard form, I can make the left hand side 0. So I'm just going to move the 51 by subtracting, and for 14x I'm going to add to both sides. So for what we have now, okay, we got 0 is equal to x squared. Now negative 12x plus 14x, okay, that's going to be a plus 2x. And for 36 minus 51, Okay, that is going to be a negative 15. And here we have a trinomial that is factorable. Okay. So you have with x squared, so this will go to x and x. And factors negative 15, where the sum or difference will be on the plus side at 2. So we're going to have more weight given to the addition than to the subtraction. And so we now are at the stage where we can utilize the zero product property. Okay, so we got x plus 5 is equal to 0. Now we will have an apparent solution with negative 5. And if we had the x minus 3 is equal to 0, we had the x is equal to 3. So we have two apparent solutions. With negative 5 and 3. And because I have an even root radical, okay, again, you have that signals that, somewhere, the principal square root rule might override the possibilities. We'll just see what happens. Okay, so we have, upon checking, x equal to negative 5. Okay, so if I have x is equal to negative 5, and I plug in negative 5 for x in the original equation, so I got 51 minus 14 times negative 5. So we have 51 plus 70, since negative 14 times negative 5 will be a positive 70. And we have plus 4. And for x minus 2, so I have negative 5 minus 2. 51 plus 70. Okay, that's going to be a 121. And you can probably already see there's going to be inconsistency, because again, you got the square root of 121, and with the principal square root rule, square root of 121 is going to be 11 and only 11. So you got plus 4, negative 5 minus 2 is negative 7, and 11 plus 4 is 15, and the right hand side we have at negative 7, so we have inconsistency. So for what this is going to mean is that the value negative 5 is not going to check out. Okay. There was a potential for there to be two solutions, but with negative 5 not checking out, that means we are going to have at most one solution. And if I check out x equal to 3, so going back, we have the square root, okay, and we have a 15, make that 51 minus. And we have 14 times 3 is 42. And plus 4. And for x minus 2, so we have 3 minus 2. 51 minus 42 is going to be 9. So the square root of 9 plus 4. And we're trying to say that that is equal to 3 minus 2. However, the square root of 9 reduces to only 3. And 3 plus 4 is going to be 7, which we have as a result on the left, and to the right we've got 3 minus 2, which is going to be 1. So we have another inconsistency, and guess what? Not only does negative 5 not check out, we also have 3 to also not quite pass muster. And so we could have had up to two solutions, but with both of these disqualified, we have for number 86, no solution. All right, now looking at what we have in the case of equations, and it's going to mention, okay, in the mix along with radicals and exponents. In the case of number 90. Okay. Okay, so I have 10 times W to the 2/3 is equal to 1/10. Now this one, sort of tricky. Again, with non-integer exponents, you can rewrite in terms of radicals. We have like the nth root of a to the m and a to the m over n. Okay, are two different ways of saying the exact same thing. Okay, and we have now with 10 times w to the 2/3. All right, now the 2/3 degree is applying to only w, not to 10. And I'll tell you what I'll do here. I'm going to go ahead and just isolate the w to the 2/3. Okay, so you got 10w to the 2/3 over 10. So this would be w to the 2/3. Now for 1/10 divided by 10, that's like taking 1/10, and if you divide by 10, that's like multiplying by the reciprocal of 10. So you have like 1/10 of 1/10. So right now we have w to the 2/3 is equal to 1 over 100. Okay. Now rewriting w to the 2/3 in radical terms. Now the denominator, okay, indicates that the type of radical is going to be a cubic root. And w to the 2/3, okay, that's going to be the cubic root of w squared. And now we're going to free up w squared upon cubing both sides. Even though 1 over 100. Okay, now the upside is that the radical is going to be taken care of. And so here we have the variable expression to be freed up. But the arguably downside is that if we didn't have a small enough fraction to begin with, it's about to get even smaller because you have like 1 over 100 times itself times itself. Yeah, so you have like 1 over 100 squared is like 1 over 10,000, but cubed you're looking at 1 over a million. So you got w squared is equal to this very small fraction. Now, and we're still looking at solving for w. So with the radical out of the mix, fractional exponent out of existence, okay, we now have the square root property of equality to encounter. So if I go from w squared to w, you can say that you're like x squared is equal to p, where x squared is represented by w squared and p is represented by this small fraction. We have x equal to plus or minus the square root of p to be represented by w is equal to plus or minus the square root of 1 over 1 million. And so for what we will have here, okay, like a million is going to have a square root that will reduce to 1,000, and just like 1 over a million, the square root would reduce to 1 over 1,000. So in the case of w, okay, we'll have additive inverse fractions that are rather small with 1 over 1,000 as well as negative 1 over 1,000. And now for what we have in quadratics, okay, and we have the crossover. Okay, once again, looking at both real and complex solutions. And for what we have in 104, now we have in the variable t, I got 10t squared plus 1210 is equal to 0. And you have your option. You can either isolate the 10t squared or go ahead and divide by 10. There's no one pathway. That's exclusive. Okay, and we'll just go ahead and divide by 10. Okay, so we just have in the rewrite. Okay, we'll have t squared plus 121 is equal to 0. And getting the t squared by itself. Now, a difference of squares you can factor, but here I have the sum of squares, and this is not factorable into real integer terms. So isolating t squared, the t squared is equal to negative 121, and a partial bit of history repeating, and that partial bit of history that repeats we have again with the square root property of equality. So going from t squared to t, have that t is plus or minus, okay, the square root of 121, and just sort of restating, okay, so plus or minus the square root of 121i, and 121 is a perfect square value, and so the square root of 121 is going to be 11, and for the square root of negative 121, that is going to be 11i. So we're going to have for t, okay, two complex additive inverse roots with 11i as well as negative 11i. And just one more thing too, I haven't explicitly gone into this, and it has been kind of just a brief part of chapter R, and this is going to kind of come up in a sense more frequently once we get into linear equations and graphing concepts, and this is for what we have for solving equations for a specified variable. And in the case of solving equations, okay, for a specified variable. Okay, now some of you might have had chemistry or might be taking chemistry, and you have something like the ideal gas law. Okay, and let's say that if you have like P times V is equal to N times R times T, and you're looking at solving for V. Okay. Well, what we would have here, okay, is that you got V on the left-hand side of the equation, and we can undo the activity to the left where V is multiplied by P. So you can get V by itself upon division. So you got P times V over P. So the P's on the left will go out, and we had that V is equal to nRT over P. And also, if you have, let's say, we'll stick with this same formula. And let's say that if you're looking at solving for t, okay. Okay, so you got PV is equal to nRT and t is on the right. And guess what? I can isolate the t, undoing not just the multiplication by r but also by n. So I can just go ahead and divide both sides of the equation by nr. And upon doing so, we have that PV over nr is equal to t, and just flipping it over, like b is equal to a is equal to b format, and having t on the left, and we have that t is equal to p times v all over n times r. Okay, so you just have like working with items in multiplying and dividing. And let's say that here's one. Okay, so you have like the common, so you have like density is equal to mass over volume. And you're looking at solving for V. So the D is equal to M over V, so I can get out of the fraction mode. So I can say that I have D times V is equal to M over V times V. And the V's will cancel on the right. So we'll have D times V is equal to M, and solving for V, okay, so this time the D's will go out, and so we have like the volume is equal to the mass over the density. And just another thing too, just to change it up a little bit, if you've got something like, let's say, inner radical, and we'll say that we have the square root of 2 times c is equal to 4g over 3, and you're looking at solving for c. So right now we have the square root of 2c is equal to 4g over 3. And what I'm trying to solve for c, but it's part of the product 2c, and where the product 2c is inside the square root. So I can get rid of the radical upon squaring both sides. And we have upon doing so, okay, so I got square root of 2c squared. Okay, so this will become 2c and for 4g over 3 squared. So 4 squared is going to be 16. And we've got g to the second. And 3 squared is going to be at 9. And going from 2c to c. So if I divide by 2, okay, so 2c over 2 becomes c, and I'm taking 1/2 of 16/9 of g squared. Think like this, dividing by 2, same as multiplying by 1/2. Okay, so I have 16 over 18g squared, and you could have gone ahead and cross multiplied, but for 16 over 18, okay, that is going to be reducible to 8g squared all over 9, and that would be the outcome for C. And there'll be some of the variable manipulation, especially as there's some of it in chapter R, but there's going to be some of it also in chapter 1, okay, once we get there.